So trigonometry, sines and cosines and tangents. So let's have a look at them and start with the sine and cosine rule that you may have come across at GCSE. So the sine rule allows you to find the lengths and angles of a triangle. It doesn't have to be equilateral or right angled or isosceles, it can be any triangle, and it's given by this equation. So a over sine A equals b over sine b equals c over sine b. So it's basically saying the ratio of the lengths to the sine of the angles are equivalent on opposite sides. And this can also be flipped upside down for this. And that means if you have, if you know two angles and one side, you can find the value of the other side. Or if you have two sides and an angle, then you can find the value of the other angle. So you just need to be able to manipulate the equations. So if you've got a over sine A equals b over sine b, then a equals sine A times b over sine b. And just be able to manipulate them and use them to solve problems. The cosine rule, if you take the same triangle again, it's slightly more complicated. It's in this form. And this is the form it's given to you in the exam. I think you get it in the formula booklet. But if you want, this is to find the value of A. If you want to find the value of big A, then you need to be able to manipulate it to move it across the sides. And then do cos A equals b squared plus c squared minus a squared over 2bc. So just be able to rearrange this equation for cos A, and then you can find the angle using the cosine rule. Like that, and then like this. And then it doesn't just have to be the values A. If it's B or C, then you just change it about a bit. So if it's cos B, then you just replace where you have the A in this equation. So replace where the A you have in this equation with the B, and replace the B you have with the A. It's fairly straightforward. It just depends on how you notate the triangle. So have a look at the graphs of the trigonometric functions now. So if we've got a sine graph, it looks like this. It's at 0, 0, and it goes up and comes back down again. And the amplitude is constant at each of the maximum and minima. And you see here the value of y equals 1 gives multiple values of x, and it continues to travel on to infinity this way and back to infinity that way. So if you get sine of x equals 0.5, then you'll get multiple values of x out if you do sine to the minus 1 of 0.5, say. Same thing applies to cosine, but it looks like this, so it starts at 1 instead. And the tangent graph looks like this, and we'll come on to why it looks like that in a minute. But now it has an asymptote at 90 degrees, at 270 degrees, and at minus 90 degrees, minus 270. And again, it carries on to infinity and minus infinity. And it carries on to infinity with the asymptote too. So we'll have a quick look at transforming these graphs. So if you do sine x times 6, then it changes the amplitude from 1 to 6, and all the sine values are times by 6. And then if you do sine x minus 3, then it just moves it down by 3. So you just need to be able to apply the same graph transformations as these as you do to any other. And I'll just have a quick look at sine x and cos x on the same graph together. You can see that cos x is just the transform of what the sine x looks like. It's just been shifted along 270 degrees or backwards 90 degrees, whichever's your preference. You might do the equation tan x equals sine over cos x. So where sine x is 0, or where sine x is 1 and cos x is 0, you get sine over cos 1 over 0. That tends to infinity, and that's why you get the asymptotes on the tan x graph at 90 degrees. It tends to infinity. So thank you for listening. Remember to like and subscribe if you found that helpful, or ask any questions.